Question 2 is about thermodynamics, and there's a lot of information given in the question. The key things to note are that the volume doubles from state 1 to state 2. Doesn't tell us what happens to the pressure, but we do know that it's an ideal gas and that the temperature is the same in both cases. In which case we can assume that if the volume doubles, the pressure here must halve, so it will be a half of P1. If we move down and have a look at the graph, we can see that the initial state, P1 and V1, has already been plotted. We've already said that the volume tells us in the question that the volume has doubled into the state 2. So that will be somewhere on this line, double V1. And that we know that P1, the pressure, has halved in P2. So that will be somewhere along this line. The point at which those two meet is here. So that's where I'm going to draw it as a cross. The graph that we'd expect is a curve, a hyperbola, and it has to go through both of those 2 points. So it would look something like that. Part B isn't shown here for some reason, but we can still go through the answer for it. It asks to explain why, in terms of gas molecules, why the pressure decreases when the volume increases. Well, if we've got a larger volume, the molecules have to travel further, which means that they collide with the walls less often. Resulting in a lower pressure. The second process for parts C and D changes the temperature in order to increase the pressure. Here it tells us that the pressure is returned to its original value. The volume is the same in both cases. And it asks us to find out what happens to T3, what happens to the temperature. We must have doubled the temperature in order to double the pressure. Both of those, absolute temperature is directly proportional to pressure. So we need a straight line that goes through the origin and the existing point that we've already got. Something like that. It'll be easier to do for you to do with a ruler. Part D then asks us to explain in terms of the motion of the gas molecules why the pressure increases when the gas is heated. Well, we know that when there's an increase in temperature, that's actually increasing the kinetic energy of the molecules. So the kinetic energy of the molecules increases. This means that the speed is faster. So molecules are moving faster. That has 2 separate effects that increase the pressure. The first is that causes more collisions or more frequent collisions. And those collisions are going to have a higher velocity. Which means that there's a greater impact force. Both of those cause a greater impact force and therefore a larger momentum change at the boundaries. Part E asks us to calculate the final temperature after both of those 2 processes. We know that the temperature started at 20 degrees, which is equal to 293 Kelvin, and that stage 1, or process 1, the gas didn't change in temperature, so that stayed the same. After that, we increase the temperature in order to increase the pressure. We know that PV equals nRT, and so T is proportional to P at a constant volume. That means that because we doubled the temperature, because we doubled the pressure, we need to double the temperature. So 293 times by 2 gives us 586 Kelvin. Alternatively, you could have used the expression P1 over T1 equals P2 over T2, and it would have come out with the same answer.